Hello everyone. Let's continue on with our Module 4 material in the CIS-115 or 120 Python class. This video is to cover the various loop patterns that you may encounter when writing programs. Those patterns are mentioned on the checklist for this week, so I'm going to switch over and share my desktop with you so you can see the checklist and we'll look at each item. So here is number 3 on the checklist where it starts talking about the loop patterns. These patterns are linked to the textbook, so this is what we would call embedded material in our class, so the textbook is integrated with the checklist. So the first item, and you see it says you'll be required to identify specific loop patterns. So the first one, probably the most simple loop pattern to talk about, is the counting pattern. Now, why is this stuff important? Well, if you don't know how to write a loop to count, then you will not be able to, write a program to, say, count how many taxpayers there were if you were working for the county or anything else. And so there's just a plain counting pattern. There's also a plain accumulate pattern. And then we have some variations of those. So let's click on the link for the counting pattern and take a look at the textbook material on that. So when I click the link, you can see it took us into the textbook, and right here where I'm highlighting, this is the textbook showing us the counting pattern. Now, when someone counts, if you were to count using your fingers on your hands, you'd go one finger at a time, right? Well, check out this loop pattern here. Here we have a for loop, okay? Each time through the for loop, this line gets run, because remember, what's part of a for loop is indented underneath that loop construct right here. So count plus equals 1 is indented, and that makes it part of the loop. When this loop cycles one time, that's called an iteration. An iteration of a loop is just another name for a cycle of a loop. If you think of looking inside a washing machine or a dryer while it's spinning, the dryer is spinning those clothes over and over and over. That's what our loop is doing here, is just rolling over and over and over. So I'm going to take this code, copy it, and we have to always with Python be mindful of indentation in our programs. And so when I paste it in, I'll probably have to fix some of the indentation. And I want to talk about what's going on in here. So I'm pasting it in now. You can see that I am going to have to get rid of this indentation. So backspacing that out, and count plus equals 1 should only be indented once. Okay, so what the book is showing you is based off of having some sort of a list of items. I'm going to change that. I'm going to simplify this code a little bit for you. Let's say we wanted a for loop to roll through the numbers starting at 0 and stopping at 9. So 0 through 9. I would write that like this. Okay? So this is going to roll through there starting at 0 and stopping at 9. Okay, and just to prove to you what it's doing, I can put a print in there. Okay, I'm printing my loop variable I. Each cycle through the loop, I'm going to print it. Okay, so let's run this and see what happens. And you can see it started at 0 here. It stopped at 9. Now, your book said this particular pattern where we're bumping something up by 1 each time through the loop, or each cycle or iteration, each time that loop cycles, okay, we're bumping it up by 1. That is our counting pattern. Now, there are two things you have to remember about the counting pattern. The first thing is that you always set your variable that you're using to hold the count equal to 0 before you get into the loop. So, and there will be questions on your homework that have things messed up, and you would need to know that always when you start a loop to count things, you would set the counting variable to 0, okay, before you get into the loop. So we set it to 0, and then each time through the loop we bump it up by 1. Now this right here is Python shorthand for this. Count equals count plus 1. So you could write that code either way. The book shows it to you with the shorthand way. I'm showing it to you the long way, just so you, hopefully, if you were having trouble understanding what this line is doing, the long way of writing it may make more sense to you. So what is this line doing? Well, the first time through the loop, I is going to have 0 in it, because we said start at 0. Okay, we're going to print the 0, which happened down here, and then count has 0 in it, so 0 plus 0 is going to be the first time through the loop. Count is going to end up with a 0 in it. Okay, second cycle of the loop, it rolls back up here. Now I is going to get a 1 in it. Okay, I is going to get a 1 in it. We'll print that 1, and then 0 is what was in count, right? 0 plus 1, now count has a 1 in it. We roll back up again. Now we're getting a 2. So we're going to print that 2, and then 1, which is what was in count from the last cycle of the loop. 1 plus 1 is going to be 2. And so it just rolls through here just like you were counting it on your fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And that's all it's doing. Now, if we wanted to know what the count of these things was at the end of our program, we could put another line in here and say print the count is, I'm just putting some text in there so that it's real plain what I'm doing. Okay, and then print the count variable out. So now we can run it and we'll see, what should the count be? It should be 10, right? Because we started at 0. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we should end up with a count of 10 when this is all over. So I'll clear my lower window, the shell window, and I'll run this again, and you can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the count is 10. So this is our counting pattern, just a plain counting pattern. So that's the first of the patterns, this one. Remember, the things about this that are important are you always set the count to 0 before you get into the loop. Each time through the loop, you're bumping your count up by 1 each time. So that's a counting pattern. You're bumping something up by 1 each time. There's a variation of that pattern that's called the filtered count pattern. So how would we know the difference between the regular counting pattern and the filtered counting pattern? What does a filter, if you have a filter on your furnace for your house, what does that filter actually do? It keeps certain things out, right? It's designed to catch the dust or the particles in the air. Of course, nowadays with coronavirus, they have HEPA filters, and those are supposed to actually catch some of the bad virus things that are in the air too. Same thing for the mask. So with a filter, we're keeping certain things out. So this filtered pattern actually has everything that our normal counting pattern has, but they've added this to it. They've added an if statement. So if you were asked to identify a pattern, and this would be just a regular count pattern because there's no if statement that's happening inside the loop. If we were only going to count the odd numbers, in this range here from 0 to 9, okay, you and I can look at it and say, well, the odd numbers out of that are 1, 3, 5, 7, and 9, okay? Well, how could we do that in this count? We could put an if statement. We could use the modulo against I, which is what is going to be, that number is going to be each time through the loop. And we could say if I modulo 2 double equals 0, then we want to count that number. So, whoops, let me undo that and tab over. So this is a filtered count pattern. Why is it filtered? Because it's got an if statement inside it. So you're going to need to be able to recognize a plain counting pattern like we were talking about before. You're also going to have to be able to recognize a filtered counting pattern. So how many odd numbers should there be in that list of numbers here? Well, there's 1, 2, 3, 4, 5. So I count 5 numbers that are odd. So let's see if this gives us a count, the count of odd numbers is, okay, I added that to it. So let me clear this out and I'll run it. You can see the count of odd numbers is 5. So what were those numbers that it counted? Well, if you wanted to know what it was counting, you could obviously put a print statement as part of your filter expression here. And now we can see what those numbers were. Okay? And let's see, I wanted to make it odd numbers, sorry. So let's make it not equal to 0. Because what this is saying right here is take I, divide it by 2. If the remainder is not equal to 0, then we must have an odd number. So let's run that again. 1, 3, 5, 7, 9. The count is 5. Good thing we printed it, huh? Because I didn't have my expression right to begin with. Okay? You can see when I had it double equals 0. Okay? So here's where I fixed it. Okay? So this says take the number divide it by 2. If the remainder is not 0, which means if we divided something and this was a 3, 3 divided by 2 has a remainder of 1, so 1 is not equal to 0. It got printed. Okay? So, that's a filtered count pattern. What do you need to remember about filtered counts? Well, it's got an if statement inside the for loop, right? Or the while loop. You could do the same thing with a while loop. We talk about while loops in the last week of the module. But we have an if statement inside the loop that makes it only count certain things. Okay? Certain things. So, that's a filtered count pattern. All right? The accumulate pattern is probably one that we use the most in programming. If somebody asks you to find the sum or the total of something, you heard me say those two words, right? The sum or the total, okay? Sum or the total. If somebody asks you in a question or a task to find the sum or the total of something, then what should pop into your head is, I need to use the accumulate pattern. The accumulate pattern. So, sum or total. It's easier when they're asking for a count because it has the word count in it, doesn't it? If they wanted you to get me the count of the odd numbers, well, that's a counting pattern. Okay? If they wanted the total of the odd numbers, then that's the accumulate pattern. The accumulate pattern. So there's a difference there. All right? So let's go on and write some of these, some code to do the accumulate pattern. So here's my loop again, okay? The things to remember about the accumulate pattern is you usually have some variable. It doesn't have to be named sum or total, but it sure makes sense if you name it something like that, okay? I'm going to make some changes here, and I'm going to take the if statement out to begin with, and we'll the sum of the numbers is, okay? All right, so this loop starts at 0, it runs up to 9, and it's jumping by each time through the loop. So if I do this, if I write this so that it prints out I again, so that we can see what we're summing up. Okay, we set sum equal to 0 outside the loop. Each time through the loop, we're going to have this: sum equals sum plus I. Now, think about what I just did here. When we were counting numbers, what did we have right here where I'm mousing? We had plus 1. This time we have plus I. So hopefully you can recognize the difference between the two patterns, because that's really the only difference between a counting pattern and an accumulate pattern, is we're adding some specific thing up, not just bumping it by 1. If you saw a 1 right here, this would be a counting pattern. Since it has I, we're actually adding up numbers. So you remember with the counting pattern, what did I get for this loop? I got the count was 10 when I just added up the numbers starting at 0 running through 9. This time I'm going to get a different number because it's going to add all these numbers up together, you can see, what did I get? The sum of the numbers is 45. That's a lot different from the count, wasn't it? That's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. That gave us 45. So that is your plain accumulate pattern. Okay? Remember, this is what's different between the accumulate and the count pattern. All right? So next, let's do the filtered accumulate pattern. The filtered accumulate pattern. Now, what's different with the filtered accumulate? It's got an if statement inside of here. It's got an if statement. We're only going to add up certain numbers. Okay? So we're going to put an if statement in here to make this a filtered. And we could use the same example of odd numbers. If I modulo 2 is not equal to a 1, okay? So what's this going to do? This is going to get me the sum of the odd numbers, not all the numbers, but the odd numbers. So what should that be? Should be 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7, 16, 16 plus 9, should be 25, I think, if I did that right in my head. The sum is 20. Okay, I don't have my loop set up exactly right here, do I? If I is not equal to 1. Oh, if I modulo 2 is double equal to 1. Okay, let's try that. Yeah, 25. Okay. So this is saying take the number, divide it by 2. If there is a remainder, then it's an odd number. So there you go. 13579. Sum of the odd numbers is 25. So what do you need to remember about a filtered accumulate pattern? It's got the if statement inside the loop, just like a filtered count had an if statement, okay, inside the loop. So what's different between a filtered counting pattern and a filtered accumulate pattern? This is what's different. What I just highlighted right here. The plus 1. Or excuse me, the plus I. Okay? The plus I. So, if it had a 1 here, a plus 1, that would be a counting pattern. If it has some variable name right here where I'm mousing, that is an accumulate pattern. Okay? And again, the book shows it like this. That's just shorthand for saying sum equals sum plus I. Okay? So if it's got a variable name here, it's an accumulate pattern. If it has an if statement inside the loop, that makes it a filtered accumulate pattern. Okay? So we've talked about a counting pattern where you add 1 each time through the loop. We've talked about a filtered counting pattern where you have an if statement and you add 1 each time through the loop. We've talked about the accumulate pattern, which we said if somebody tells you to give me the sum of something or the total of something, then you would be using the accumulate pattern. The accumulate pattern has a variable name here that gets added each time through the loop. Okay? If it's a filtered accumulate pattern, your loop is going to have an if statement in it, some condition, and it's going to have this variable here. Okay? The other patterns that are talked about here on the announcements are the search and the extreme pattern. The search and the extreme pattern. So, what are you doing when you search through something? What are you actually doing? If I gave you a list of names and I said, I want you to give me the names that start with A out of this list, what would you do? You'd go through each name on that list and look to see what the first letter was. And if it's an A, then you'd add it to your list, right? So, can you see how we could use a loop to do that? So, the main thing to remember about the search pattern, which is right here in your book, okay? The search pattern, okay? You see it says it's a variation of filtered count, okay? So, what it's doing here is it's got a loop that's still rolling through each item in the list, but it's checking to see if it's equal to something. If it is, it's returning it. So it's just a variation of a filtered count pattern. I don't actually think there's a question like this on our homework or on our exam where you would have to recognize the code. But they might give you this word that says if you want to see if something is present, if you want to see if something's present, then you would use the search pattern. Okay? The extreme pattern, we're going to make the first item the largest item. And then if we're looking for the biggest thing, we're going to make the first thing we find the largest or the biggest. And then we're going to roll through every single item. And if we find one that's bigger, we're going to make that item the largest. So, the question that you might come across would be, if you want to find the largest or the smallest value in an array, then you would use the extreme pattern. The extreme pattern. So, let's pop into the homework and see what kinds of questions they give us. See if we can pick out the questions that it asked me on my particular homework about the patterns. Okay? Let's see if we can find those pattern questions in the homework. Remember, your homework is very close to the exam, so it's always good to do the homework first before you do the exam. So I'm skipping over everything that does not have anything to do with our patterns. So let's see if we can find a pattern here. So far I haven't found one. We could talk about this just to see. They're asking us what's wrong with this this particular bit of code right here. It says the problem statement, sum the numbers from A to B, including B. Okay? What's wrong with it? Well, sum the numbers. It's got the word sum here, so what pattern should we be using? The accumulate pattern. Remember, with the count and with the accumulate patterns, okay, we had to start our total. We had to start our total at what? 0. So what are they starting their total with? They're starting it with B. So that's one problem that I see right there, is this should be total equals B. I mean total equals 0. This should be total equals 0, not B. So we need to fix this line, okay? The range statement here, if we wanted to sum up everything starting at A and including all the way up to B, then right here where it's got B for where it's going to stop, this would actually stop one before B. How could we fix that? This should stop at B plus 1, because remember, your range statement stops one before. So two things wrong. Total should be total equals 0, and here it should be B plus 1. So the range should end at B plus 1, not B, and the total should start at 0. So that would be the correct answer to pick right there for that question. All right, here's one. You see, it's actually asking us to solve this problem. Determine the sum of the Carmichael numbers in the range A to B. Which pattern would you use? I always have people that email me and say, we haven't talked about what a Carmichael number is. How am I supposed to know the answer to this? Does it matter? Let me ask you. Does it matter what type of number a Carmichael number is? It's a special type of number, right? It's only certain numbers. It's not every number. If we wanted only certain numbers, the sum of certain numbers, okay, it has the word sum in it, so automatically when we see that word sum, we know we need to use the accumulate pattern. They only want certain numbers in that range. Only certain ones. So if it's a special type of number, then it's going to be a filter. So what kind of pattern? A filtered accumulate pattern. Filtered accumulate pattern. Here we have one that's asking us, what pattern does this function implement? I told you they'd give you some of those patterns. So you could go back and look at the textbook and figure this out. But let's see if we can figure it out. Okay? What are they doing each time through the loop? They're adding 1 to it. What type of pattern did I say it was if they were adding 1 to something each time through the loop? Again, I'll ask the question. What type of pattern if they're adding 1 each time through the loop? What do you do with your fingers when you're counting? Okay? That's a counting pattern because it's adding 1 each time through the loop. It doesn't have an if statement inside our loop, so it's not a filter. So it's just the counting pattern. That wasn't too bad, was it? Okay, let's look at this one. This is another one of those questions that you just have to think about. If you want to solve the problem, determine the sum of the numbers from A to B. Which pattern? When you see the word sum, it's going to be an accumulate pattern, right? They didn't say specific numbers. They just said the numbers. So sum the numbers. That's automatically going to be just a plain old accumulate pattern. Accumulate pattern. Okay, based off of those patterns that we talked about, all you have to really know to fix this question, to answer this question, is to be able to implement those patterns. So they said they want us, this code should sum the numbers from A to B including B. Where does total need to start? Where does total need to start? Total always starts at 0, right? Just like if it was a counting pattern, it would be count would always start at 0. So this is messed up right here. Total should be total equals 0. Okay? This is adding the variable, not 1, it's adding the variable I each time through the loop to total. That looks good. It should start at A, because it said from A right here. It should start at A. It should stop at B. So they put B plus 1 because this stops 1 before B. So the only thing that's really wrong with this code that I see is right here, this line. Total should start at 0, not A. Okay? We'll do one more, and you can see it's giving me a lot of these. So you got to know how to make this stuff work. Okay, which pattern is this going to use? It's got the word sum in it. That's going to be the accumulate pattern. The accumulate pattern. So, did it say certain numbers, or did it just say all the numbers or the numbers? It's all the numbers, right? So, not certain ones, all the numbers. Okay? And it's got to go up to and include B. So, let's look at this. It's setting total equal to 0. Okay? Remember, if it says sum, that's the accumulate pattern. It's not certain numbers, so it's just going to be a full accumulate. Okay? No if statement inside the loop. Okay? So it's set total equal to 0. It starts at A. It runs up to B plus 1. Okay? It's jumping by 1 each time. It's adding I to the total. I don't see anything wrong with this. This is perfect. This is a perfect accumulate pattern. So, only thing I can do is really pick that. All right, well, we've been at this for about 40 minutes. So, that's the patterns. That's how you need to be able to recognize the patterns. I'm looking to see if it gives me any other questions here about recognizing a pattern, and it doesn't. So that's our lecture on the various loop patterns. Remember, this stuff is in your book, starting right here where it says the counting pattern. That's on our checklist for Module 4 this week. Okay, those items are right here. Whoops, I can't drag. I can mouse though. Number 3 on the checklist is specific loop patterns: counting, filtered count, accumulate, filtered accumulate, search, and extreme. So good luck with those. You now know how to do the problems on your homework, and you also know how to recognize and implement those patterns. Take care.